All right, everybody. Welcome to Weld Inspection Technology Module 5. A lot of things to cover today. Number one, we're going to start about documents. This stuff is tedious and boring, but it's very important to understand the differences between all the different documentation, okay? All this stuff matters. It really does. Purchase orders, we start talking about separation, equipment control, material control, so forth. Contract documents, codes, standards, specs, the differences between all of them, how they apply, and versus recommended practices and drawings. We start out basically on the drawing section, okay? And most of you have been through our blueprint, you've been through a lot of our drawing stuff at this point, but now we're going to talk a little bit more of how it might apply in the welding fabrication field versus the small widget part manufacturing field, okay? So if you can imagine, just a real quick general overview. Most of you that have taken a SolidWorks course or an AutoCAD course, you know by the time you turn all the relationships on within that part, you can see just this overwhelming amount of relationships. Everything's equal, horizontal, vertical, and you don't see that on every print, right? You see a few things, but then you also assume tangency. You can look at the call-outs for the dimensions and so forth. But there's some of that that you just know because of further training. Well, imagine on a fabrication or a job site, there's a lot of that because they can't spell out every little detail of the right triangle when there's over 6,000 right triangles just in one fabrication piece, say of a scaffolding or something like that, okay? So some of this stuff, definitely we assume concentration, we assume perpendicularity, similarity, 90-degree angles, right triangles, stuff like that when it's applicable. And if it's drawn on the actual blueprint that way, it is also applicable without spelling it out, okay? A lot of times on a blueprint, you're going to get a blueprint of a building and say it's in a square. You can measure it, but you assume it'll show one corner's 90 degrees, 4 of them are equal, they're all the same, okay? So if I'm looking through the book, I'm going to start out on page 5-2, second paragraph down on the left-hand column underneath the introduction heading. About halfway down that paragraph, it starts out, some of the documents a welding inspector may use include drawings, codes, standards, specifications, all the things we talked about in this first part, okay? The next paragraph talks about it's essential for the welding inspector to have an opportunity to study all applicable documents before the start of the job. And that's the part that I can't stress enough. Before. Usually when you're going to bid a job or you come on a job, the very beginning, the most crucial thing you can do is study all the documentation. Number one, what's the material prep? How do you isolate your materials? What's the code for it? Do we need to worry about purchase orders? Is it there? Do we have MTRs on everything? Absolutely. What's the hold points? What's the requirements for inspection? Does every part need to have a visual inspection? Does every layer need to have a visual inspection? You have to know all that before you start, okay? And then make sure you adhere to it all the way through that as well. Okay, so 5-2, we talk about a lot of things in here, particularly part size, geometry, base and filler metals to be used, requirements for hold points. So what is a hold point? Okay, so when we're going to look at some of this stuff here, requirement for a hold point can be many different areas, processing skills, and so forth, okay? The extent of inspection, again, this is a 20% inspection, is every weld inspected, and so forth as well. Material control requirements, that's what I talked about MTR, a paint system, a different system that needs to be set up for it as well, okay? So let's go back and talk about the first one, hold points. A hold point would be a good example for any of you that have done pipe in our shop, you know, or even group plate. I want to see the root before you continue on, right? So there's a perfect example of a hold point. Say you've done 3/4 of the weld pass of the pipe that's contained, and it's not going to get an NDT shot, so it's not going to get x-rayed or ultrasounded. It all has to be done on visual. Then I'm going to inspect. I want you to leave 1/4 of that pipe open for a visual window for me to go in and inspect it. And then I'm going to watch you put the last 1/4 of that weld in. Okay? It's a good example of a hold point, and also tells you some of the other topics were just in that same conversation. Extent of the inspection. Does it require non-destructive tests, ultrasound, and x-ray, so forth. We're going to move on to drawings next, okay? The drawings describe the part structure in graphic detail. Drawing dimensions, tolerances, notes, weld, and welding details and accompanying documents should be reviewed by the inspector. You have to know what you're inspecting, right? So, particularly in this situation, your math skills need to be up to snuff. You also need to be able to understand your tolerances, what are the dimensions, and occasionally you might have to be able to go back and forth between metric and the U.S. customary system, okay? Some people, there are imperial, some people call it, AWS calls it U.S. customary instead of imperial and so forth, okay? Amongst the trades, there's a million different ways to discuss a lot of this stuff. But in this case, we're using U.S. customary or the SI, also known as System International or metric. Make sure you review the notes particularly, and then the list of materials is usually given on there as well. So here's a good example. Number one, we got the drawing of the part. We can see how it's made. We apply to it which pieces are a branch, which ones are headers, which ones are supposed to be coped, which ones are not. Okay. But if you notice here, detail A is typical. So we come over to the notes. A, handrails with lengths not equal to 18-inch center space, inside post equal distance, otherwise 18-inch on center. Okay? When you look this PowerPoint up as you're going through it, you'll be able to see these a lot better. It actually gives you a detailed parts list of which parts and what. These will tell you exactly what the dimensions are. It tells you 2 5/8 here, but it may give you a bigger spec, showing you your section view coming down in this direction as well. Detail is a 90-degree corner. Returns 2 radius and 2 L part A4. Okay, so then you got to come back over to your part, which is A4 required, and they tell you a different length. They have the length offsets differently here than they do here. Okay, and again, you don't even see a symbol here that shows you this is a right triangle. You assume a right triangle because this is a 90-degree elbow. So you assume that this and this are perpendicular to themselves at this point. You know, a lot of our program, we talk about what is the call out. Well, on a lot of this stuff, in reality, we don't have to call out. It is known that it is supposed to be parallel and 90 degrees, okay? If not, it will specify it. Okay? Materials. So here it gives you out the material, 1.5 inch schedule 40 pipe, okay? We're talking about the dimensions. Now we come back in here and we start talking about the actual dimensions from outside to outside dimension. Some places will give you center to center, some outside to outside. Pay attention to those little details like that, okay? They make or break you in a lot of situations. Especially when it comes to handrails, you also need to know what the OSHA requirements are at the job, or if you're on that or if you're on a job site that requires MSHA, they may have more stringent spec as well. Again, we're talking about the weld and inspection piece. And quite simply put, it is this simple. Like as the welder yourself, you may not be held as liable to some of these other standards, but when you come in as a welding inspector, they want you to know a lot more than just the weld inspection piece. You should know some general construction guidelines, okay? Some general rules, some general applications that should be applied to and adhered to while you're on the job. Tolerances, plus or minus 0.125 unless otherwise specified. So up here it tells you plus or minus 1/4 inch. So this is a different one. Otherwise, everything else in this note says that the tolerance is 1/8 of an inch. Naturally, 125 is 1/8 of an inch, but you're going to have to bounce back and forth between fractions and decimal. Okay. And then the big print giveth and the fine print taketh away. Okay? It's the old adage that most people have told me, and it's very true. Pay attention to the detail in the notes. Everything within the documentation is done in that pattern. The general guidelines are the bold overview, but the small notes and the small print and detail are the ones that set a lot of the odd stipulations, so to say. okay? I'm going to take a little break here. I'm going to read a little bit from the book. It's page 5-3. Okay. Right-hand column. About the second paragraph down, it says, notes can be classified as general, local, or specifications, depending on their application on the blueprint. General notes apply to the entire drawing and are usually placed above or to the left of the title block in a horizontal position, which right here are the notes, okay? Down at the bottom of that, read through that section alone, and then basically what it's telling you is the note will usually be followed by the phrase, except as shown, except as noted, or unless otherwise specified. And right here is exactly what we just did, the 1/8 inch, unless as specified. And it specified it in this print. Now everything else is not specified, so it adheres to this tolerance, okay? Those are the little things that make a big difference, that make or break a weld inspection, or any manufacturing process at all, actually. Okay, page 5-4. We start talking a little bit about some of the hold points, okay? Page 5-4, left-hand column. First paragraph down, well, the first sentence in there actually starts out, the weld inspector should be aware of this before starting any welding whatsoever. So just remember, you're not just in charge of the welding, but the cutting process, how we got to it, especially in certain alloys. Was it air arc, was it saw cut, was it not? I mean, for example, just cutting a piece of pipe with a flame bevel oxyacetylene, number one, did you mark it cold or did you mark it hot, right? So particularly on 2-inch pipe and smaller, the CTEs, or the coefficient of thermal expansion, makes that pipe grow. It could be up to 1/8 of an inch, 1/4 of an inch, especially if they're a close piece, right? Think about when you're welding those coupons together. As they get to welding together, they grow together, or they'll start out 1/8 of an inch and all of a sudden it swells shut by the time you're there. So if you cut one side while it's hot and then you make that measurement, it's already grown, and you're going to cut it again, and all of a sudden it's going to shrink up, okay? By the time it cools back down and it gets up to put in on the fitted piece, say it's in this section right here, and it's cooled down at that point, all of a sudden it's going to be too small because you cut it while it was hot and ground, okay? So, a few of those things, the size, the length, the preheat, the cutting, those are all things to be taken into consideration before the start of any process whatsoever. Some of the applicable documents, reading off of page 5-4, left-hand column, some of the applicable documents might also dictate hold points during the fabrication process. Hold points are specific pre-arranged steps in the fab process to permit interim inspections. They can also be for material call-out. Certain materials you may have to let it cool back down before you can weld it, or it may have to have a preheat on it as well. Okay, tacked in or as welded, or preheated or post-heated also. Inspection required. Sometimes the inspection is done as a fit-up. Inspected and require a 3-part piece. Number one is as fit-up usually. When we get into the print, it'll tell you, your root opening is supposed to be 1/4 of an inch, as fit plus or minus 1/16. So you can go a 1/16 below or a 1/16 above, and that's now your tolerance as fit instead of just on the print. Okay, that's an inspection point. And what we're trying to do is sometimes I've seen a lot of bolts welded inside of projects because they weren't cut to the right length, and somebody just went in there and started whipping a whole bunch of electrode in there, filled that gap, and yeah, they filled it up. But guess what? On the inside of that root, it looked horrible, right? And there's a bolt in there, and somebody just kind of welded over top of it because somebody wasn't very good at the oxy-fuel cutting, or they didn't do a good job of fitting this piece up, okay? And that's important in here as well. Okay. After that, then you can weld, usually say, put the root pass in, and then I want to see how much it's distorted. It might be another piece, okay? If it's warped or bowed or anything else, that might at that point be a point for rejection or to get a piece out of there. I remember first starting out when I was younger, putting out on a coal mine. I had a gentleman that definitely, his eye was a little bit more crooked than mine. And I'm holding this big piece of steel up like 12 feet, and I'm trying to hold it with, got a chain pole holding it up, and I'm trying to align it and get ready to tack it, and I'm moving it slowly, and he tells me, okay, we're good there. And so I tack it, and then I come back, and then I tack multiple places along it as we're going along. And I didn't check it myself, and I should have. But by the time I'm done with it at the end of the day, I've done about 10 feet of weld and stitch patterns, you know, a little bit here, a little bit here. And I go back, and the thing is clearly looked like a rattlesnake going down it. And I said, man, did you even look at that? Oh, I didn't even look at that. I was just looking at it in this direction, this way, not down this direction. So it was a lot of work to cut that back out of there and make sure that it fit back up. And I wish I would have checked it myself as the welder, just to see if it was somewhat narrow and straight looking before I started welding it. Good example of the whole point there, okay? All right, we're going to talk the next piece. 5-4, right-hand column. I want to talk about the second part, the second paragraph in there. Before welding, the inspector should review welding procedures to ensure that all combinations of material, thickness, process, position are adequately covered. Also, what type of welding electrodes, what preheat, all those other things. I think you're starting to get the point, so I'm going to kind of lay off that a little bit, okay? We're going to move on to this, visual or other NDE, be prepared for it, how to set up for it, and also this tells me how to schedule for it as well, right? So if I need to do a non-destructive examination on the first 20% of the welds, or say the first 20 welds out of 100, okay? I need to know when am I going to start welding, what are we going to be, and then to schedule that x-ray crew at that time, which also means I need to schedule everybody else, the entire job, to shut down while they come in and using radiation to be able to x-ray that, all right? Some of those things are just part of the inspection information, the documentation that you'll get used to. Preferably the first couple times you're going to be with somebody else, hopefully helping out as well, okay? What's the test method? What's the test procedure? Make sure that that paperwork is in line. I can't tell you how many times I've tested for shutdowns, and I've actually had companies call me and say, well, I want you to test these 4 welders for this stainless, and I want you to test these 3 for this steel. Just run an ER70S. And I said, well, do you want them all, do they all need to be stainless? No, these guys haven't welded stainless. They've only welded steel. So let me tell you what happens, right? Is they're going to have their 6 first welders come in, and that they know can pass a stainless test, and maybe the other 3 haven't, and they're still kind of needing that experience. And they're going to sneak them in, and we're going to give them a test on 70S just steel, instead of 308 or 309 or 316, whatever. And sometimes, a lot of times, the inspectors, he's just looking through the paperwork of the fabricators, the documentation for the codes and the certifications. I can see a name, I see GTAW, and you'll just flip through it. Unless you take a fine-tooth comb and look at it and say, oh, it's for ER70S-6, which is steel, versus 308L or 309L, they're going to try to sneak you in on that job, okay? So you got to be careful about it. The positions, make sure they're acceptable, and you have to know which code as well, right? So for certain codes, let's give you a good example, AWS D11, right? They're going to say you're allowed, you do it to a pipe test on 2-inch pipe, so you're allowed to go from 1 inch to 4 inch, okay? Now if you do a 2-inch super coupon on ASME, you're allowed to go anywhere above that. You can go any diameter, but you can only go up to 1.5 inches thick. Okay, so different codes have different limitations and what positions as well. All right, so that's the other things. Now we need to know which code we're welding to. Okay, before we get there, I want to read you a little blurb about codes on page 5-5. The first category under the heading codes, first category of document to be discussed is a code. By definition, a code is a body of laws as of a nation, city, etc., arranged systematically for each reference. Okay? So this is exactly what it means. It is a law. Alright? And then it goes on to talk about, it says, when a structure is built within the jurisdiction of a city or state, it must often comply within certain buildings codes. Since a code consists of laws having legal status, it will always be considered mandatory. Okay? So the most important thing here, these are multiple places to do it. Now if you notice something, guess who's not on here? ANSI, right? The American National Safety Institute. They approve standards, but they don't write any standards. That's everybody's, like, when you first started down in welding, one of the first ones you seen, and even beginning in SolidWorks is ANSI standards, right? They approve standards, but they don't write the codes or specifications for them. These companies do. American Welding Society, American Society of Mechanical Engineers, American Petroleum Institute, American Bureau of Shipping, the Department of Transportation, there's military standards and others as well, okay? We went through the code, we know what it is. There's certain types of codes. We just read about building codes, but within that building code, the electrical or the plumbing code might be even more strict or stringent, okay? Fabrication, the bridge welding code as well. You know, if you're building a bridge, you're going to be under D15, plus you might also be under the actual city building code, which might be 10 times more stringent than D1.5 is, okay? All right. Codes that do have legal status, they use the words such as shall and will. Okay, that's really important that you know those two words mean they are mandatory. Okay? Methods to determine compliance. Sorry, come back here. There's other ones to use. We talk about should and could instead of shall and will. Shall and will are usually associated with codes. All right. Should and could are usually associated with standards and specifications. All right. See if I miss anything here real quick. As you can see, there's a lot of stuff out of the code section that we'd like to talk about. I would definitely know what D1.1 is, what's your structural welding code for steel, aluminum, welding code, ASME, what's B31.1 versus B31.3. One's power piping, one is process piping. Okay. Which sections are out of there? ASME sections. So, number 1. Care power boilers, pressure vessels, section 8. There's also 3 divisions of section 8 as well. Section 9 are the welding qualifications. Okay, so almost everything has to adhere to the welding qualifications where we test them, but then the actual in production welds may actually have to adhere to an ASME section 8. Okay. Yeah, and then of course naturally here's the materials, right? So for any material, ASME section 2. Part A is dealing with materials, ferrous materials, and then there's also A 5.1, which we talked about in section 3 and 4, right? 5.1 and 5.5 are the handling of materials, or feller metals, and so forth. Number C, part C, things like that, the standards within them. All right, read through those. We're going to start in on standards, okay? Something established for use as a rule or basis of comparison in measuring or judging capacity, quantity, content, extent, value, and quality, etc. So, right here is the ASNT, which is one of the documents that